Okay, this is problem number 7. And notice that the formula for generating the value of the terms is telling me something interesting. It's saying that the nth term is equal to the value of the term before it, plus the value of the term before that one. So for example, suppose just for example, I wanted like A25, the 25th term. I would have to add the 24th term plus the 23rd term. Where am I getting those from, those values? Because if n is 25, then n minus 1 would be 24, and n minus 2 would be 23. So that's telling me to get the 25th term, I would have to add up the 24th term and the 23rd term, because the general formula for the value of a term is telling me any particular term is equal to the term before the one that we're trying to generate plus the term before that one. Okay, I have to go 2 terms back. This is called recursive. Recursive means we need to use the values of previous terms in the sequence in order to get the current term. Okay. Earlier problems did not deal with recursive. Earlier problems in the homework dealt with explicit formulas where you could just generate any term on its own without needing the previous ones. But in these cases, because the value of a term is defined as some combination of the previous values, you have to have those previous values before you can get the current value. That's why it's called recursive. Okay. So in order to generate the values for a recursive sequence, you have to start from the beginning. Okay, so let's go ahead and start at the beginning. Let's start with A1. Okay, so A1 is given to us. In fact, A1 is given to us and A2 is given to us because they have to do that because we need the 2 terms before a particular term to generate the value of that term, because we're going back 2 terms here. And so I can't really begin computing things until I get to the 3rd term. So the 3rd term is going to be the term before the 3rd term, which would be the 2nd term, plus the term before the 2nd term, which would be the 1st term. Do I know what those values are? Yes, they're 1s, right? Here they are. They're 1 and 1. Okay, so my A3 would have a value 2. Let's go another term. Let's go to A4. A4 is going to be the term before the 4th term, which would be the 3rd term, and then the term before the 3rd term, which would be the 2nd term. Now, what is the value of the 3rd term? I already know that value because I just figured it out, okay? The 3rd term is what I just figured out here. It's the 2. Okay, so it's going to be 2 for the 3rd term, plus, do I know the 2nd term? Yes, it's right here. That's my 2nd term. Okay, so what do I get? So I'm adding up the 3rd term and the 2nd term in order to get that 4th term. 3rd term plus 2nd term. So I'm getting a 3. All right, let's go to the 5th term. 5th term is going to be the 4th term plus the 3rd term. How come? Because I'm being told that to generate any particular term, the nth term, I have to add up the n minus 1st and the n minus 2nd term. That means I drop back by 1 and then another one. Drop back by 2 terms and add them up. Okay? So what is the value of A4? Well, the value of A4, the 4th term, we have right here. A4 has the value 3. Okay? So that's my A4. What about my A3? A3 has the value 2. Okay, and if I add up the 3 plus 2, I'm thinking 5, right? Well, for practice, let's try one more. Let's go A6. So A6 is going to be what? The 5th term plus the 4th term in this particular case, because we're told to add 1 term back plus the term before that. Okay, what is the value of A5? Well, the value of A5 we just found, right? The value of A5 was 5. What's the value of A4? A4 was a 3. And so if I add up the 5 and the 3, looks like I'm getting 8, right? And I can keep going. Okay, so I'm going to have to keep going to generate my A9. Okay, so for A9 is going to be what? A8 plus A7. So you have to keep going. And it turns out the answer you should get here is 34 if you keep going with my numbers. So if you want to practice with my numbers, you should eventually get all the way down to 34 as your the value of your 9th term. Okay, and then you can go ahead and apply this to your particular version of the problem. All right, so let's go on to the next one. Okay, this is problem number 8. And notice they're giving us basically the same kind of setup as before. Any particular term, so the nth term is equal to the value of the term right before the nth term plus the term before that one. Go back one and then go back a second. Whoops, n minus 2, my bad. Okay, go back one and then go back another one. Okay, so we're going to go back one term, go back by one term, and then go back again. Go back another one. Go back one more term. Or another way to think about that is one back, go back one, and then two back from where you are. Okay, so let's begin. So when we begin, remember we're going to need the first two values because the first time we can actually apply this formula is for the third value because we need the two before a particular term. So my A1 they have to give us, which they do. A2 they give us. To generate A3, what do? We just add up the second term and the first term. How come? Because that's what it's telling us to do. Take the two terms right before the term we're at. Okay, and the values are A2 is a 3, the A1 is a 1, and 3 plus 1 is obviously 4, right? Let's go to A4. A4 is going to be the term before the fourth term, which would be the third, plus the term before the third, which would be the second. Now, the one before the third term, we just figured that out, right? We just got that guy. The A3 was a 4. Right? What about the A2? The A2 was given to us, right? The A2 was a 3. So I can just add those two numbers together, right? So I'm going to get the A3, which was a 4, and then the A2, which was the 3, right? Where are these coming from? I'll just color code it for you again, just so it's easy to spot. And we're going to add those together. And of course, we're getting what? We're getting a 7. Let's try one more. Okay, well actually I'll let you guys do the next one because they're asking for the fifth term. So if you check this, my A5, if you go ahead and do this, you should end up with, so we're going to kind of use the process, you should end up with 11 here, okay, with my numbers. Okay, but you can go ahead and check that and make sure you do, and also then you can apply this to your version of the problem. Okay, all right, so let's try the next problem. Okay, this is, let's see, problem number 9. Oops, hang on. Problem number 9, and in this case, they're asking us to generate an explicit formula, meaning we just want a formula that can compute any particular value right off the bat. It does not depend on the previous values. If it depended on the previous values, it would be called what? It would be called a recursive formula. But explicit means we can just compute any particular value in the sequence directly without knowing the previous ones. So we have to kind of play detective on these when you have to generate a formula. These are a little bit puzzling. Okay, you have to kind of you have to kind of like puzzles a little bit. So let's just write my terms here. So my first term would be A1. My next term would be A2. I'm just going to write a little list here. And let's write the index number of the term. The index is the n number, the little number at the bottom. So the index for the first term is 1. The index, or the n, if you like. Okay. N is 2 for the second term, 3 and 4. And now they're telling me the value that they want the term to have. So the values that they want these terms to have would be, for my first term, I want a 3. For my second term, I want to get a 2. For my third term, I want to get a 0. And for my fourth term, I want to get a -1. And now our job, and it's going to seem a little bit strange, but this is our job, we need to figure out a way to take these index numbers and use them as an input to generate these values. And it has to be a rule that works for all of them. I need a rule that takes the index numbers and generates these values for the terms. How do I know the values? These are the values they want me to generate. These are the values of the terms. Okay? These are the index numbers down here. So I need to take those index numbers and convert them into the values. And the way you want to sort of do this detective-wise is look for a pattern. A pattern that I see is that I keep going down by 1, right? I go down by 1. I go down by 1. I go down by, from 2 to, oops, that should have been a 1, my bad. Whoops, let me change that. Oh, no. Okay, so this should have been a 1. This should be a 0. Sorry about that. Okay, it's a good thing we check for the pattern. Okay. They're giving us, I guess, 1, 2, 3, 4. They're giving us 5 values, so I'll put down A5 here. I have to convert a 5 into a -1. Okay, I apologize. Sorry about that. Okay, so a 5 would have to be converted into -1. But the pattern is the same, right? We agree with the pattern. I'm going down by 1 each time. Going down 1, down 1. I keep going down by 1 every time. Now, if you're going down by 1, now what's causing you to go down by 1? What's causing you to go down by 1 has to be, what's causing changes are these index numbers. The index numbers change. So every time the index numbers go up by 1, the value of my term is going down by 1. So that suggests that I'm subtracting these index numbers. In fact, what could I subtract 1 from that would generate a 3? So we're trying to think, what can I do? So I want something. Let me change colors on you a little bit here. So I need some number minus 1 should give me a 3. Some number minus a 2 should give me a 2. Some number minus a 3 should give me a 1. How do I know that this is the pattern? Because these are my indexes, and I notice that as my indexes are going up by 1, every time the index goes up by 1, the values of the terms are going down by 1. So the way to make that happen is use the index numbers, subtract your index numbers. If you subtract your index numbers, the value is going to keep decreasing. Every time the index goes up by 1, every time the index goes up by 1, the values are going down by 1. How do I know the values are going down by 1? Because they are telling me the values I'm supposed to be getting, and I can see they're going down by 1 every time. Okay, and the way to make values go down by 1 as the index goes up by 1 is to subtract the index. When you subtract a bigger number, you get a smaller value. Now, can I figure out a number to start with that makes this work? Something take away 1 is 3. Can you figure out what it is? I bet it's this. 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3 is 1. How about here? How about 4 minus 4? 4, this 4 that we figured out minus this index number. The index number for this term, the fourth term has an index number of 4. 4 take away 4 is giving me what? A 0. Okay. How about here? What's the index number for the fifth term? 5. What's 4 take away 5? -1, which is the value that we're supposed to be getting. So the idea is that if we claim that the, essentially what we're saying is A1, so we're saying A1 is 4 minus 1. We're saying A2 is 4 minus 2. We're saying A3 is 4 minus 3. We're saying A4 is 4 minus 4. We're saying A5 is 4 minus 5. Okay? And we're getting the correct outputs that we're supposed to get based on what they told us we're after. We're after these numbers. We're supposed to generate those numbers. We're getting them. Okay? This formula, this pattern is doing that for us. How do we write this pattern out? The 4 is not changing, is it? The only thing changing is the index. The only thing changing, essentially, is this index number. Right? The index number is changing, which means I'm changing and these numbers here. These are my index numbers. Now, what's a name for an index number? The name for a general index number is n. Okay, the general term would be called an. Okay, right now, a1 is when n is 1. Okay, this is when n is 1. When n is 2, we have a2. When n is 3, we have a3. When n is 4, we have a4. When n is 5, we have a5. Okay, so what's changing is these n numbers. These are n numbers. That's my n. My n keeps changing. As I go up by the terms, as the terms keep clicking up by 1, my n numbers are going up. Okay, so that says that the formula has to use the n number. The 4 doesn't change. So my formula has to start with a 4. The 4 is not changing. But I seem to be subtracting the n number. I'm subtracting a 1, then I'm subtracting a 2, I'm subtracting a 3. For the fourth term, I'm subtracting a 4. For the third term, I'm subtracting a 3. For the second term, I'm subtracting a 2. For the nth term, I seem to be subtracting the n. Okay, let's see if this formula works. Let's check it. Let's check what would A1 be. A1 would be 4 take away the n value of 1, which is 3. Now, is 3 what we're supposed to get? Yes. What about A2? A2 would be 4 take away the n value of 2, right? 4 take away 2 is 2. Is 2 what we're supposed to get? Yes. A3, the n value is 3. So we'd have 4 take away the n value, because we're doing 4 take away n as my formula. The n value here is 3. 4 take away 3 would give me a 1, which is what I'm supposed to get. So this pattern is working. This pattern is generating the terms, the values of the terms that I'm supposed to have. Okay. The next question is, what is the 34th term in the sequence? So how would I get the 34th term at this point? Well, for the 34th term, that means n is 34, right? So I can use this formula. an is 4 take away n. So A34 would be what? 4 take away the number 34. Because my n would be 34 for the 4th term. 4 take away 34 is negative 30. So you should be getting, negative 30 in my version of the problem. Okay, so my answer would be negative 30. So my formula to generate the terms, my explicit formula, is that the nth term is 4 take away the index number. 4 take away 1 would generate the 3 that they want me to get. 4 take away 2 would generate the 2. 4 take away 3 generates the 1. 4 take away 4 generates the 0, etc. Those are the numbers they wanted me to be generating. So this formula is generating them for me. I can then use that formula to figure out the value of the 34th term. Okay? So this one's a bit challenging, and so you kind of have to play detective. You have to realize, well, I know my indexes are going up by 1 because that's how we label our indexes. They keep going up by 1. First term, n is 1. Second term, n is 2. Third term, n is 3. Fourth term, n is 4. Fifth term, n is 5, etc. I see that my indexes are going up by 1, and I can tell that my values have to be going down by 1. So if I subtract the index, every time the index gets bigger by 1, then because I'm subtracting it, the value I get is going to go down by 1. So that suggests that I should be subtracting my index. The only question is, what am I subtracting it from? And we see that if I use a 4, it makes the numbers match up. Okay, 4 take away 1 gave me the 3. 4 take away 2 gave me the 2, etc. Okay, so that's where this formula came from. All right, so let's try problem 10. Okay, problem 10, again, they're asking us to generate a sequence, or generate a formula for the sequence. And so when we have to generate a formula, that means we have to play detective. So first thing I'm going to do is I like to have a common denominator everywhere. These are not written with a common denominator. So let's get a common denominator. So I've got 3 over 2. Then I've got 2 over 1, which is just the number. Any number by itself can be thought of as being over 1. Then I've got 5 over 2. Then I've got 3 over 1. And then I've got 7 over 2, etc. Notice some denominators are 2's and some are 1's. So I'm going to convert everything to a common denominator, which in this case would be 2. So if I multiply by 2 on top, 2 on the bottom on these guys, times 2, that generates a common denominator. Okay, so I'm going to end up with 3 over 2. This would be 4 over 2, because 2 times 2 is 4 over 2, 5 over 2. Then 3 times 2 is 6, 6 over 2, 7 over 2, etc. So these are the values of the sequence terms I should be getting. It's just easier to work if everything has a common denominator. That's always my first step. If there's fractions involved, get a common denominator so it's easy to compare things. Now, the next question is, let's just make a table of what the values of what the term should look like. So when n is 1, I'm going to be dealing with a1. Okay? So when n is 1, my a1 is supposed to be what? 3 over 2. When n is 2, I'm going to have term a2. What is a2 supposed to be? My second term, 4 over 2. When n is 3, that's the third term, which we write as a3. The index is 3. And we're supposed to be getting 5/2, 5 over 2. Excuse me. When n is 4, that's term a4. We're supposed to be getting the fourth term here, which is 6 over 2. And they'll do the last one. When n is 5, we should be getting the fifth term, which is, they're telling us 7 over 2. So again, the point is we need to figure out a way to take these n numbers and convert them into these values. And it has to be the same pattern, the same rule has to work all the time. I'm trying to convert the n numbers into the values of the term. So I'll just keep circling these just so we can visually see the pattern. I'm trying to take these n numbers and convert them into the term values. So how can I do that? Well, I already know that, so let's just write down that my general nth term, and I need a formula for it. And I already know the formula is going to have to involve a fraction because I have to generate fractions. And I already know what the bottom of the fraction is. What's the bottom? 2, 2, 2, 2, 2. Do you spot the pattern? The pattern is, yeah, the bottom's always 2. Okay, so I already know the bottom of my formula is 2. So really what I need is I need to generate these numerators. Since I know the denominators are all 2's, I need to generate the numerator, really. I need to convert this 1 into a 3. So I need something that converts a 1 into a 3, that converts a 2 into a 4, converts a 3 into a 5, converts a 4 into a 6, converts a 5 into a 7, etc. So what converts a 1 into a 3? How about multiplication by 3? Would that work? So how about n times 3? Or 3 times n? Would that work? Well, what is 3 times 1? 3 times 1 is 3, so that works. How about when n is 2? 3 times 2 is 6, not 4. So this is not working. So 3 times n is not a correct way to do this. How else can I convert a 1 into a 3? If I cannot do it by multiplication, how about by addition? Can I convert a 1 into a 3 by addition instead? Sure. What do I add? I add a 2, right? So how about if I try, let's see, we can do a different color here. What if I try something like this? What if I try n plus 2? Would that work? Well, what's 1 plus 2? It's 3. That checks. How about when n is 2? What's 2 plus 2? 4. That's the numerator I wanted, right? So that checks. How about here? What's 3 plus 2? I'm adding 2. I'm taking my n value, my index value, plus 2. Because the reason I chose that is because it makes the first one work. And I'm checking to see if it makes the rest work. 3 plus 2 is 5. It's working. In fact, if you check all the way down, it's going to work. So that says that my pattern is that I have to take my n value and add 2. Now, can I reduce by canceling these 2's? And the answer is no. You can never cancel anything that's adding or subtracting. So do not be tempted to cancel these. Okay? They don't reduce. If things are adding or subtracting, you cannot cancel. You can only cancel things that are multiplying. Since the 2 is adding, I cannot cancel it. So this is my formula that generates the terms. How come it works? Because the bottom is always 2, so putting a 2 on the bottom is fine. And then the numerator of the terms is always 2 higher than what the index was. 5 is 2 more than 3. 6 is 2 more than 4, etc. 7 is 2 more than 5. So that says take your index value and add 2. Take your index value and add 2, and you'll get your value of the numerator of your term. The denominator is always 2. Okay, so that's my formula. That's my explicit formula for my terms. Okay? They're not asking us to type that out. They're asking us to now use that, in my case, to get the 28th term. Okay, so how would I get the 28th term? A28 is going to be what? Well, the bottom's 2, denominator's 2, and I'm going to have what? N plus 2. But my n is 28. So I'm going to get what? 30 over 2 in my case. 30 over 2 is 15. Okay? So my answer here would be 15. How did I generate it? I first figured out the explicit formula that generates all the terms for me, and then I applied that formula to the particular n value they gave me, n equals 28 in this case. Okay? So it's a bit of a detective game. You have to kind of be a detective here. These are a little bit tricky. All right? Okay, let's go to the next one. Okay, so here we are on problem 11. And again, we want an explicit formula to generate these terms. So when n is 1, we want my a1 to have the value of 0. When n is 2, that means the term is going to be a2, and we want a2 to have a value of 3. So I'm just going to keep doing this. When n is 3, we want a3 to have the value of 8. When n is 4, we want a4 to have the value of 15. When n is 5, we want a5 to have the value of 24, etc. So again, what we want to do is we want to figure out a way to take these n values and convert them into these output values or values of the terms. I want to convert a 1 into a 0. I need to convert a 2 into a 3, etc. I need to convert a 3 into an 8. I did this pattern to keep going all the way down. Okay? So how do we do this? Well, first of all, let's look at the spacing between the terms. Is the spacing constant or is it changing? If it's constant, like last time, we noticed the terms were going down by 1 each time. And so I figured, hey, let me subtract the n value, because as the n value gets bigger and you subtract a bigger number, you'll get a smaller output value. And that was working for us. Okay, but in this case, they're not spaced equally. The spacing seems to be growing, right? These guys are 3 units apart. These guys are 5 apart. These guys are 7 apart. These guys are 9 apart, right? The distance that the terms are from each other, the values of the terms, is getting larger. So it's what's called not linear. Linear means it's the same distance all the time. Okay? This is not linear. It's the distance is changing all the time. In fact, it's increasing all the time. So we're not going to have, when the distances are increasing, the distances between the terms, between the values of the terms, is increasing all the time. If it's increasing, that tells me that I need powers. I need a power on the n value. Because the n value is what's generating the outputs, right? These n values are what I have to do to generate those outputs. I have to use the n values. So those n values need an exponent on them. So let's try the simplest exponent. What would be the simplest exponent? Well, how about 2? Right, exponent 1 is not really a power because n to the 1 is just n. It's no real exponent. Okay, n to the 2 is not n, right? N to the 2 is n squared. That's something different. So let's try the simplest exponent that's not a 1. Let's try a 2. All right, that's the rationale. The rationale is I need the distances to keep growing, and so I need a power. And the simplest power that's not a power 1 is a power 2. Power 1 is not really doing anything. It's not really putting a valuable exponent on there. You need a power 2 to begin to have an exponent. So let's try it. Let's try n squared. So let's make a column here for n squared. Okay, so in this case, 1 squared would be 1. Well, it's not a 0, but there it is. It's a 1. How about 2 squared? When n is 2, 2 squared is 4. When n is 3, 3 squared is 9. When n is 4, 4 squared is 16. Why am I picking square? Why am I squaring the n? Because I see that the distances between the terms is growing, which suggests that somehow the n has an exponent on it because it's getting bigger and bigger all the time by increasing amounts. Okay? Now, can I take these numbers that I'm getting from the n squared and see how those relate to the term values, right? These are the term values that I'm supposed to be getting. So this is what I want to get. I want to generate these term values. So I can generate those. How do I generate these? Are these n squared values anywhere close to the term values? Is there a relationship between them? Let's see. 1 is, the value 1 here is 1 bigger than the 0. Does that pattern continue? 4 is 1 bigger than 3. 9 is 1 bigger than 8. It looks like the n squared is 1 bigger than the value of the term that we're supposed to get. So how can I correct for that? So I'm going to say that the nth term is what? If I say the nth term is just n squared, does that work? Well, that would mean a1 is what? 1 squared, which is 1. That doesn't work, right? I should be getting a 0. It says a2 should be 2 squared, which is 4. That doesn't work, right? Because I should be getting a 3, etc. So I can't just use n squared. N squared seems to be 1 too big. It's too big by a factor of 1. Too large by a factor of 1. So how do I reduce it by 1? How do I reduce a 1 to a 0? How do I reduce a 4 to a 3? How do I reduce a 9 to an 8? The way you reduce by 1 is subtract 1 from the result. Okay, let's check that. Okay, now let's check a1. a1 should be 1 squared take away 1. That works. a2 should be 2 squared take away 1. That works. a3 should be 3 squared take away 1 if we're following this pattern, which is 9 minus 1 is 8. That works. a4 is 4 squared take away 1. So that's working, right? So this pattern's working. So this is my explicit formula for the terms. Takes a little detective work to get it. But once I have it, I can easily apply it to get the 20th term. How do I apply it to get the 20th term? You just plug 20 in for n, right? And bada boom, you got it. Okay? You could do bada bing too, I guess. All right? Either way. But these are a little challenging because you have to play detective. You have to notice, distances are growing, so I need a power. Try the simplest power, compute the values of that power, see if the values sort of match up or get pretty close to the terms that we're supposed to be generating. And in this case, we see that they're always one too large, so I subtract one and I'm all set. Okay? All right, and that was that. That was fun, right? Yes. Let me Google it. Yep, Google says that was fun. I just checked it.